Good morning. I see most of you have a good drawing on your whiteboard, a complete drawing. What we're going to do is we're going to make a little art gallery of physics drawings. We're going to, in a few minutes, not now, we're going to put all the different whiteboards along the aisles so everybody can easily see, and we're all going to walk around and look at each drawing. So you're going to see all of the other monks' drawings, and if you notice anything you want to change, you can go back to your whiteboard and make a quick change. So I'm going to remember that when we draw an arrow, the size of that arrow represents the strength of that force. So looking around the room, I think many groups need to have a quick conversation about how long should their arrows be. So I'm going to give you another minute to discuss in your groups, make some final changes, and then we're going to have our, we call it a gallery walk. Okay.
So, when I draw a force diagram, I ask myself the following two questions. Have I taken into account the interaction of the earth with the object, which is not touching? And I mean the gravitational interaction. And have I taken into account all the objects that are touching the object of interest? And the second question that I'm asking myself is, for the object of interest, is the net force zero or is it not zero?
Are you ready to share?
Yes.
Well, that wasn't a very loud yes. Remember, these are whiteboards, very easy to change. So let's go ahead and take your whiteboards, and we're going to put them, oops, sorry. Well, actually, the ones in the front, we'll just put them sideways or someplace where people can see. So move all your whiteboards to the side where people can walk along and see them.
Tadanda di carbon digejua, samata godugola ni thala diksharo ches. Dinin judu thungura jongi di.
So move them closer to here.
Carbon samatsu sharo ches langa ithala.
And stand up.
Ani ya sharo nas sama.
And go walk around the room and look at the different whiteboards.
Otab di carbon di diksaro thala. Di langa ni sama khali le phene ni siro ches. Ruga shamba denjo khali thiwe.
Go look at all of the whiteboards. Look at each drawing.
Ta carbon sangma taro ches an thana shi remove sangma remove rere chin yakushin zero nas.
So many good drawings in the room. And after 3 days of class and just a few opportunities to make these drawings, I see wonderful improvement. My advice and encouragement is to keep making these drawings, practice, practice, practice. Draw in your notebooks, draw on the whiteboard. I was sleeping in my bed this morning and I was thinking, there's a force pushing down, there's a force pushing up.
Any of
you doing that also? This is the sleeping part or the thinking about the forces?
Sleeping part.
The sleeping part, okay, yeah. So this group here had a good drawing. And would you mind volunteering to come and explain the forces on your diagram? So remember, we're a scientific community. So we need to listen to his ideas. Think carefully. And offer advice if we think there's anything he should change. So please explain the forces on your diagram.
Okay, shady. So there's a glass slab underneath.
Then the demo you see the blood jura, she no longer Darcy or Darcy Sajua, or Darcy to be sick the pile.
So frictional force is acting this way. This is the frictional force.
You know, this ship, the Tabati will ship here to one in the day under the Tabajua, Tabati with the ship rain or
there's more force on this side from the rope.
Why?
Because there's a frictional force here. As compared to the frictional force, this is higher, that's why it goes that way.
That she said the board, and then she Mando and Thomas Ra. The Tabaj, the Tabaj, and she got a lesson, and you got side tension man and the side tension margin over a shoe. Nikashi, this shoot cousin, did she choose you, did you want to more lesson, remote some over the in she needs a Chibomado.
I found in some drawings that gravitational force, they have represented this bigger, but we feel that both these forces are equal.
Okay. So did you all understand his description? Is there anything you would disagree with or suggest?
So I feel there's one more force over here because there are objects inside this tray. That's why the weight of this pulls it down, pushes it down. So he said, are you asking about these nails or the pins, clips? He said yes. So he said, like, we have considered these two as one object.
Okay.
As we have mentioned before.
What about him?
So his question is like, since you have represented these two forces as equal, right? So why this pan is falling down if both the forces are equal? If you say it falls down, it means it breaks from this end. The string breaks, he said. If you say if it falls, which means the string breaks. But it's not falling. So there is no differences in forces here. It's because of this like less frictional force, it goes that way.
These are all very good arguments we're hearing.
He's saying we are not saying it's falling down, but it's like going downwards, right? So why it's going downwards? So he's saying it moves with the same speed, the speed of the rope and the iron.
I don't need to put him on the ropes for too long. No. So now we get up So you've heard from your peers that they're concerned about the length of these arrows. Whether or not you agree with their concerns, that is your decision to make. But my question is, do you understand what they're saying? Do you understand their concerns? Okay, great. Should we?
I have a question. Do you agree that this one is a greater force than this one?
Okay, he doesn't agree. Okay, so
That's a good point. We want to thank him. And is it okay if we borrow this drawing for a few more minutes? Okay, so thank you.
So yesterday on the skateboard, one person was pulling. What was the other force? He
was sitting on the skateboard.
He was sitting on the skateboard, right? And so one person was pulling, right? So one person was pulling. What was the other force on the skateboard Bryce object?
There's a frictional force. Frictional force on the other object.
The frictional force. Okay. And so we are trying to decide now if those two forces were equal or if the force by Stamades was greater.
Both forces are equal, they're saying. Some are saying the force by Stamades is more.
So let us imagine that we do the experiment again, only we put oil on the wheels. What will putting oil on the wheels do to the frictional force?
It becomes less.
It will decrease the frictional force. If I were to pull with the same force as I did before, what would Bryce's motion be compared to before when the wheels were not greased?
Moves faster.
So he would move faster and faster, but the rate at which he would move faster and faster would be greater.
So faster when the wheel was applied with oil, right?
So then when an object is moving faster and faster and faster, What does that tell me about the two forces? Are they equal or are they unequal?
Ta gyoru dugu la roas. Di la du gala ta shuk ni di chikpa chagu re na kheba dugu res. Chikpa re. Both forces are equal.
The two forces that we are talking about is the force Baistamades on Bryce.
Tanda shugni ke je shigi yorwas. Di khar lana chik di stamatus ki Bryce la shug ya di res.
And the force on Bryce by the frictional force on Bryce by the floor.
Ning shug shen di khari cha dur lana tar shug jura. Ya sai tanda shala ki Bryce la shug ya di cha dur res tar shugi. There's a change now, there's a difference. There is less frictional force in the second part.
So they cannot be the same. So that is also consistent with what the general rule that we came up yesterday. When the object speeds up, the forces are not balanced, they are not equal, they do not sum up to zero, but one force is bigger than the other. So you also said, so is that okay? That actually tells me that because this is speeding up, not because this is moving, but because it is speeding up, this force has to be greater than that force. It was also very correctly pointed out that the speed with which this moves to the right is the speed with which this falls. So if this is speeding up, this must be speeding up. Now, if this is speeding up, let's actually see it.
Watch how fast is this block moving. Or watch how fast is this tray moving. Now that you all know what's going to happen when I let go, right? You know this is going to move like this, right? Pay attention to how fast is it moving and how is that speed changing. Chig ni sum. Because it didn't make an accident, I can do it again. What did you notice?
It moved faster and faster.
It moves faster and faster.
So this was moving faster and faster, this was moving faster and faster. So if this is moving that way faster and faster, does it have a zero net force on it or a non-zero net force on it?
Is it zero or not, right? No, it's not zero.
It is not zero. Therefore, this cannot be equal to this force. Which is interesting because the string does not pull with the same force as the weight of the falling object.
Ta thanda kubegi thengi shubjora dida thanda jibo thanda chabi ma saya jora chabi di ni chabi gi jibo dida di shubjora dida gangi kubegi then shubdi jibo chagi yo mares.
So then this has to be small.
Chezang di gangi chuma buyu res.
Okay? It is very pleasing to see that the diagrams that you had drawn were so good. So now we are going to think about a situation where the object is moving, it is not at rest, and the object is neither speeding up nor slowing down. Okay. All right. So what I'm going to do is I'm going to start Bryce and the chair, thought as a single object, moving, and then after I get them moving, I want to push in such a way so that they move with constant speed.
The Bryce the pupjesh the dini move chikse is thangbo go to video tangra di tang du golani jose jura chikrang shay chidu ani shuk jura dil babige is.
So I do not want us to worry about the process, the time where I'm getting it to move. I want us to think about after I have gotten a Bryce and the chair moving, as they are moving with constant speed.
Ngema imba ina anzu gochuk du dil thuna shuk che chiyo thanda dikhar lana thanda dil thuna chegu yo mares thanda kharita gur lana Bryce jokse jora khorang jokse chik rang shani ta ta jora di ke chumu chagi res thanda de jokse chik rang shaye de.
Let's do it again.
I feel like I'm in a wheelchair or something.
So what we would like you to do is we would like you to draw in your notebook a free body diagram for the object Bryce and chair.
Tatanda namju remote chair jo shug remote di troches di khari gang re lana ngobo di khari cha de lana tanda Bryce ta hubja ni ngobo chik sini.
Not so I'm pushing like this. Straight, horizontally.
Tangi bugu res, budang di khari lana khaptu thela budo, thel khaptu bugus.
And I don't want you to worry about the time when I'm getting him to move.
Ta kiranzo di tunan chigwe yo mares, thangbo gozuwe jora, yogu che gozuwe di ta bugu yo mares.
But I want you to draw the force diagram at an instant when he's already moving, but moving. And he is neither speeding up nor slowing down.
The Keranzo removes Tugura, the Karil Samlutan Shaw Tugur Lawina, Bryce Yoguche, Botsuk Sajela, Josechigan Rodejua, didn't down the Samlushan any remove the truches.
And pay close attention to how long do you draw your force arrows.
The D Keranzuchi Karitunan Shiurlana, and the Shugi removed Tugal, that the Tungu Shugdi. Di shugi shukse di dai rindung di ra dil tunan chiro chis chik
So do this in your notebook.
아니 결혼서 Tibetan 들어치서 단다 리무디.
I have another drawing suggestion.
그 결혼서 리무트 해야라야 나랑 이직 마 쉐어 네비지.
Draw a little bit bigger.
리무트도 리무티스 체스 들어치스.
I've seen many little drawings.
그 결혼서 리무 망부시 통소스라스 칼도란 리무 춘주춘주 되도스.
So don't be afraid. Make a little bit of bigger drawing.
쉐고 마레스 리무 체스 들어치스.
Ten seconds.
Bryce ta kubje remote ye jara ning ju shu go mares karza chu na sayo yo dinde stru chi sarimo.
And I have a suggestion about how to draw Bryce in the chair.
The ye tik she was Bryce ta the kubje che jara ti dandi.
Here is Bryce in the chair.
Ta di Bryce kubje de jo di res.
Okay. So we do not need to think about all the details.
The shipta gala inji mi dro gugu yo mares dinde station ai digyo res Bryce kubje ga de la ngo bo chi chungyo ra.
Oh, ganapaso. So we're going to together as a class draw the force diagram for Bryce and chair.
Ta danda shu gi remove yo Bryce ta kubje ni nyam de jo di remove di tigyo ras ngo.
So what objects are interacting with Bryce in the chair?
The Bryce ta kubja jura korani la ngo bo shimba khari pinzu dewa chag dos. The floor.
The floor.
Shala di che ni. The earth. Say kula che ni. Darshu. Frictional force.
Is the frictional force an object?
Darshu lara. Darshu di ngo bo revesa. Kada ngo bo khari di pinzu dewa lara. Stomatis.
So we have the floor, planet Earth, and stomatis.
Shala di che ani say kula che ani stomatis di sum ro sa ngo bo.
Okay, let's start with planet Earth because it's important.
Say kula kechimbu ro las che zan dine go zu gos.
I think we are all familiar with the idea that there's a force of gravity.
Ta changme gi danda di kingyo ros tenshu di yo adi.
That's on, I'm just going to use the letter B for me, and chair, by Earth.
Di tenshu di ro say kula gi Bryce ta tanda kubja di niga nyam do dubeng bi tijo di korani ga res Bryce ta kubja niga sungyo res.
I think almost all of you have had these in your drawings. I think you're very good at labeling this force.
Ta kyanzo remote sangmanal di da yosha relas kailan kyanzo di shuk di da pe aku ge dos khade na shuk di ta ge di.
Are there any other forces exerted by Earth on Bryce?
Are there?
Any other forces
Other
exerted on Bryce and chair by Earth? Planet Earth.
Ta tanda on Earth you said, right?
So we have Earth, we have the floor, Earth, and stomatis. These are the three objects exerting forces. We have the Earth and this force. Is there any other forces being exerted by Earth?
Ta say kolegi shuk ge gyo ya shimba yo res shuk. Say kolegi shuk ge yo res yang gyo. No.
No. So now we're done with Earth. Now we only have the floor and stomatis.
Ta say kolegi shuk shimba yo mar da shuk ta say kolegi sa swas. Ta di jele nil hayra shala di da ani stomatis di nil hayras.
Okay. What's another force?
Ani shuk shimba di khandi chagi yo res. Force by the floor on Bryce.
And how long is that arrow compared to this arrow?
Ta tanda shale ya shuk ge yor la jara. Di shuk se thiyo na ringdung khagas thigu res di da di wa na chikpa same as this.
Same. So that's the force on Bryce. By what? What's causing
Bryce
this
la
force?
shuk yangi su cha de res ngo. Floor.
The floor. So these forces are equal, and so Bryce is not changing speed in either vertical direction. Is not.
Di shuk ni ga chik ba ra. Di la di Bryce ki yu gu che ta shuk se jura. Di gyo du yu marwas.
Right. What other forces are acting on Bryce in the chair?
The Bryce kubja ga de ga du shuk shemba khari gya de rest. By stomatus.
Stomatus. So let's have stomatus pushing this way.
The stomatus ki dijo bigya tang yu acha shasra.
So I'm not sure how long to draw this arrow, so I'm not going to put an arrowhead on it.
Ta di shuk jura, shuk ze khaga se me thanda ha umara cheza ani shuk dai go di thing me thanda.
But we can call this the force on Bryce.
And di shuk di khari chawor law hai na stomatus ki Bryce kan shuk gya yu di rest.
What other force is acting on Bryce and chair?
The Bryce kubja ga de yu jura digal shuk shemba khari yu rest. Frictional force.
The frictional force. Which direction is that force?
That way.
Okay, everyone is pointing that way. I'm also not sure how long to draw this arrow. But I know it's the force of friction on Bryce.
Di yang how mes tar shuj do di da diring lo khagas shuk se di how mes ta da chezan di dai go di thi mes di tar shu di Bryce kan la gya yu di shala di ya gya yu cha de res shu di.
Are we missing any forces?
Ta dinam shuk ma sang do es.
Okay.
No.
But we know the length of these forces, the strength of these forces, the length of these arrows.
Ta ngazo di shuk ni juda di ni shuk se how go yu res an cheza thanda da di ring dung di how go yu res.
How should the length of this arrow compare to the length of this arrow?
Ta di da jura di gi ring dung di dil duro na hades thi go yu res. Like this should be longer.
So you think this one should be longer and this one should be shorter?
Ta khiran zo shidan china dijo di ring a che dijo thunga gor lagi ras. Okay, some of them are saying no, it should be equal.
Do you want to explain why?
Kya deshe gyandu duel asti khandes.
Because you're already reaching for the microphone, I think so.
Kya ni mic jude da cheza deshe gyaro shis.
Na jiba yen karala ta tamu ne buju yen bro chawara ba. Ta nyeche tenu man rogo yoba yen sa darsu da ani karse bode. Ba buja yen shute jiba me ba nyeche chejo rogo nyeche lo ke.
So since this object has started to move, it's moving in the same. It's moving at the same speed. So. So these two forces should be equal. If these two are not equal, there will be change in the speed of the object. But the speed is constant, so these two should be equal.
So we have an idea that they should be equal in length.
They're saying no.
No. We'll return to their idea. But let's embrace this idea for a moment. If this is true, let's think about the consequence.
So
there's a force in this direction greater than the force in this direction.
Sorry?
There's a force in one direction greater than the force in the other direction.
Yes.
So, and if that is the case, then how will Bryce in the chair's speed behave?
Bryce Bryce and the Yugu che the go 100 do rest. Do your rest. There is no change.
No, if we saw when we were on a skateboard, if the force pulling is greater than the force friction, what did we discover?
The Rasu Itachi chambers, Tengi Shukjura, Ten the Shukchaina, and the wall Darshujura, Darshu that Tinshuni Duruina, Ten the Tandashuk the Choina, and Karchik dus. Darshuk Chuache, the object moves faster and faster.
It moves faster and faster and faster and faster. So, does this diagram imply that Bryce's speed will keep going faster and faster and faster and faster?
No.
It doesn't. Okay. We want you to do a little experiment. I can hang weights from my force meter and I can see the force. So we want you to find some weights and a force meter and make sure you can have the spring stretch a little bit so you can see a reading. And then we want you to, while looking carefully, move it up and down with a constant speed.
And we need to concentrate on the part of the motion where the speed is constant.
And not
pay attention to the part of the motion where the speed is changing, which is either at the top or at the bottom. So, if one force is bigger than the other, so if the force changes, I'm not going to hang this, if this is hung here, and if the force changes as I move it up with constant speed, then this would be correct. If the force does not change when I move this up with constant speed, then these two forces have to be checked out.
For this, you can hang anything you want, the weights or scissors or phone. Go, Grapaso. What did you notice?
It's the same, the reading is the same.
So, is it possible for something to be moving with constant speed without the force changing?
It's possible.
Is it possible for something to be moving at constant speed without the force changing?
Yes, it is possible.
It is possible. Write that in your book. And then go for tea. Just before tea break, we all agreed that it was possible for something to move at a constant speed without the force changing.
So je parsing ngol ngazo khari ha khor lawana ngobo chi yogu chiwe kapsu jokse thagarang chigan la jokse chigan ro thu res ra khoran la shuk ge jodi la joa ke mandro ai nei ngobo de shuk se chigan ro thu res lan ngazo gi yongsi res lan she res.
If we look at this weight, this iron,
di charge do ji se yo dinde jil ta ai nas dila.
it's pushing down with a gravitational force.
Di khol biur lawana ma thinshu chola ma biu duas.
The force of gravity from the earth is acting on this iron.
Ta di cha digala khari di chidir lawana tanda thinshu diya shu diya gya de res.
And there's also a force in the upwards direction.
An chik shuk chi khari lana ya chola yo res.
And I can move this up and down, and the force does not change.
Ta di ngobush do di ma pa ya kya chi yes. Di chiwe kapsu di shuk dila shuk se la jo dum dos.
So I can move something at a constant speed without the force changing.
Di shedu ngobu chik ni yogu chi tu res jokse chigan yogu chewa che thana she any shuk dila jo mandro ni tinde yogu chi tu jokse chiga jo tu res ngobu di.
We also know from our experience yesterday with skateboards is that if you pull with the constant force, the skateboard and the person sitting on it will go faster and faster and faster and faster.
Ta kesa ta chi che bas dinal kharchi lana ngo follow yo skateboard digan la shwe chi de che ani chi gi the res di thendu gala thengi digi kesi thewe shuk jora di shuk se chi rang gi the baina ani pe skateboard khola ga dengi mi digi jose jora yogu che di gyoru du duas.
So this drawing here implies that Bryce in his chair will be moving faster and faster and faster and faster and faster in this direction.
Ta di rimu na ta waina kugya digala Bryce de res andila du gala di rimu dil shisha waina Bryce phajol gyoru du ruas.
But that's not what was happening in the experiment we did.
Ine nganjo thanda taje che dinang la dinde chungu yo maruas.
So this is a problem.
Ta kangi di khothe der lana di res. So this looks equal. It may be equal.
So if they're equal, it would look like this.
Kesi chikpa imba ina dinde doj gu ruas.
And this would mean that the force in this direction equals the force in this direction.
Di khare tungu la waina shub di jo gyagyo da phajo gyagyo ni chikpa lagi ruas.
And just like with the spring, we know that it's possible for the net force to be zero and you're still moving at a constant speed.
Di yongsi ruasa kailana thanda kyondom shub changshub jua di lego rimba che ine ngobu di yogu che di kyokse chik rang lo yogu chi to thue jura di yongsi ruas.
This might not feel very comfortable.
Di this madewa dosh doas. Tadi. Yes.
It doesn't feel comfortable?
Deu bindu lagu ruas akinoje. Yes.
It's not comfortable.
Yeah, it's not comfortable.
But we also realize that any other drawing where this arrow is longer, that's also not good.
There rimu shimbas thio ena di ringbu thio ena ge ya ta di yo maras ya buch chagi yo mares.
So let's think about this a little bit more.
Ta di tola engyo samlo tis mangro ta is.
So what we are saying here, what we are led to conclude, is that if the net force is zero, there are two possibilities.
Kesi changshu kyondom shuk jiwa di lego rimba ina ta sirumwe ta chagin rola ora di ni yong sig res.
One possibility is the possibility that we feel comfortable with.
Ta chik si ronga jura yong si ba di khari cha dor lana ngara zo deu chore jura di yong yu res chik.
That the object is at rest.
Ngobu di sorne le yo achik che.
The other possibility that we find out here, if the net force is zero, the object moves in the same direction with the same speed.
Chik di career law and ni shira, chick di mobody sorneche, chick di mobody yogu chilures, and yogu chidugala, chok chigla, murse chick, dose chigala, duguash, hakuires.
So let's think about how that could be possible.
Tadila dugala, young sigurla, ni shira, that the condes young sigurla, ditol samlot and roches.
So we have a big bowling ball here.
And
I'm going to bring a carpet. I will exert a force on the ball to change its motion. And then the object, after it leaves my hand, it moves and slows down because of the frictional force.
And
So it leaves my hand, I exert a force. After my fingers stop touching, I'm not exerting a force anymore. And the only force then on the horizontal, in the horizontal direction, is the frictional force which slows it down. If I were to put a second carpet on top of this carpet, and I gave it the same push, what do we think the slowing down, would the slowing down be the same, or would it slow down and stop in a shorter amount of time?
It slows down. It'll be slower than the previous one.
And it will stop here. If I were now to remove this carpet and put a carpet that is made of silk, and I gave it the same push, it will go further before it stops. So, here is the free body, this is the force diagram of the ball.
And the shugi remove polo diga tiwa na di chag res.
This is the gravitational force on the ball by Earth.
Di polo gala shug di khari cha deor lana then shug di res se khole then shug di polo gala gya deor res.
This is the force on the ball by the floor.
Di gang la shug sten da di khar lana polo gala shug gya jo gya gen di su cha deor lana thanda shala di res.
And this is the frictional force on the ball by the floor.
Ta phajo shug sten sa da di khari chungyor la wa na polo gala darshu ju res ra darshu di sui gya khari gya la wa na thanda shala di gya jo di tyen res.
There is no arrow going this way because I'm drawing this at an instant when I'm not touching the ball.
Ta thande di rimuna la de la datyo yo mares di jotunge di nedan di khari tungur la na ngi polo di la bacha yo mares.
So this may be the situation where there are two carpets on the ground.
Ta di nedan khari roji ga jte la wa na sai shala di gan la 데니 띵셔레스 지간 직sek니
where it moves and slows down and stops here.
니 직두갈 하지그레 데네 고수라 데네 요구치니 델 가그레스
Then I change it to a single carpet and this becomes smaller.
안 제수응에 기타 지오 예그레스 디 하지글라나 데니니 덴직 수레스 덴직 시드 쇠두 땅으로 아폴로디 디 땅도갈라 디 슈크디마 충루두레스
So it does not slow down as quickly.
디 가해줘라 테로줘라 디 요구쇼 테로 둠마레스 디 뒤즈마 그룹레스
And then I change this carpet and I put a silk carpet and this becomes even smaller.
다 단다 덴직 디 찹라 투시기 덴지 띵바이나스 안디 마땅 와이나 다 디슈지다 파조둥에 디 딜레 충아 두레스
So on the silk carpet, it stops out there someplace.
다 투시 덴디 띵니 폴로 디 마땅 와이나스 뷰바이나스 파니마 도질 가그레스
So I could imagine a surface which is so smooth that there is no frictional force.
다 삼바나 덴디지 샤나 디기로스 뭐 잠부 슈즈 요아체 델 다슈치에 며 덴디 임바이나 안델라 슈치에 요 마레스
If that surface is so smooth that there is no rubbing of the surfaces of the ball with that surface, then there will be no slowing down.
뭐 잠부 슈 요아체 아니 뭐기 탄다 뭐 디다 아니 폴로 디 파라 다레주라 디 메바이나스 아니 테로 레주라 디 용마레스
And the ball would go and go and go and go on that surface.
폴로 디 도 디그레스 펫
So it would be moving without changing direction and without speeding up or slowing down, and the net force will be zero.
딜라주타 탄다 다레 디 메와이나 도 디그라라 디 데디 교레 두마레 태안시 테로에 두마레스 도 디그레스 아니 프랑기 탄다 장슈 주라 쿄նդum 슈디 아니 net force will be zero 아니 쿄նդum 슈디 레고 레스 디고스
So we see then that net force being zero can be either for an object that is at rest or for an object that is moving with a constant speed in a given direction.
딜라두타 탄다 단다 쿄նդum 슈 레고 인두가 롱보디 카리여레 야나 소르네 딩이치 야나 촉직로 도 딩이체 아니 요구치니 도아체 태안시 격세디 직랑 두고요레스
There is another argument that we can make.
안디가 랭귀지 쳬바 심바지 갸초레스
We started thinking about this problem at the beginning of the first session today.
따디 코르라 카뉴즈 다디 디 탄다 촉된 탐보 호랑 고축도 닝어주 삼로타이레스
In that first session lasted for 90 minutes.
다 촉된 탐보디 카가스보도 고르고라나 까마 굽주 고르고레스
Would you say that that video camera was at rest during those 90 minutes? The stand of the video camera.
촉된 탐보디 까마 굽주 고르레스 딜라드골 케란소이 카리시기 인스디 탄다 파르치디기 월 깡바숨도 디 소르네 레슬라니 시긴 베사 까마 굽주 링들라 촉된 탐보딘 파르치디 깡바숨디 소르네 레 마레 Yes, it was at rest.
If I was standing on the sun, that video camera in those 90 minutes would have moved by 162,000 kilometers.
Tanga nimagani mata oina di parchej do tadu wala kilometer gyada tukju rangis kujo tangyo tungres.
Do you agree?
Dil mutu US.
So what we mean by an object at rest or an object moving in some direction with a constant speed is not an inherent condition of the object.
Dil duta ngobudi tanda joksechi kala dugu yor lajora di tanda ngobudi korangi
without being a property of the object.
Ta ngobu digi keju mayin ba do chi yo resti.
So, for instance, we could all be on a train right now, a modern, very, very smooth train, moving across India, very smoothly with good suspension.
Ta bezun shawainas ta mekor jures tengdu ge mekor do che jambu shu yo dinang lo suspension la na phare yo do dinde jambu shu yo dinde chinang la do yo res.
And we would be able to do all the experiments that we did, and we would not be able to tell a difference whether we were moving or we were not moving.
Ta dinde gap su ta je chiwa na ngara su she thu mares yogu chigi yo mar la jora di la thu yo mares.
So forces do not tell us about motion.
Ani shuk la jora digi yogu gang la ke she thu yo mares.
Or absence of motion.
Yogu chigi yo re yana chigi yo mar la jora dil ke la thu yo mares shuk digi.
They tell us about changes in motion.
Digi khare to la she thu la wa na ngobu ke shemas yogu che jora di yo khande du me dig or she thu res.
So for instance, I could actually move this and I could change that reading.
Ta dingi yogu chini diwala loesh do che juda di che di yama gyo ta ros.
Not by moving it up at constant speed.
Di gyo di khandes tang tur lo na he gyo se chi gal ya kya wa na gyo tang thu mares.
But by changing its speed.
Ine gyo se dil gyo tang wa na an digi thanda lo nganzu di che juda di lo gyo du res.
So when we change the speed of something, then we have a net force.
Ta nganzu gi gyo se dil gyo tang wa na ani digap su khari rawor la wa na nganzu gi kyondom shuk chang shu di ra gi res.
When we do not change the speed of something,
ta khande ji bai na di ani nganzu gi gyo se dil gyo ma tang wa nas
the net force is zero.
ani kyondom shuk chang shu di le gor chag res.
So that is an idea that was a very hard idea for science to accept.
Ta di samsuj do ne dun di cherig la da ngulen che do la ora de khaku ji chag res khaku di samsu di.
And so that is an example of Newton's first law.
Ta thande she di khari gi pesun cha der la na Newton gi tentim thangbo di pesun res.
Newton's first law says that an object will either stay at rest or will continue to move in a given direction with non-changing speed if the net force is zero.
Ta Newton gi tentim thangbo khari shi gi la wa na kesi thanda changshu de le go rim bainas an ngobu chi sonne im baina sonne rang di res yana ngobu di yogu chi yo na chok khol yogu chi yo di thagarang yokse chikrang gala du yo res la jora di shi yo res.
So I think it is important for us to appreciate that Newton had never experienced a floor that had no friction.
Ta chi khari la na Newton kurangi une nyong yo mares khari nyong yo mar la na shala dila darshu che me shala dinde jikta ta che jora di nyong yo mares kurangi.
But he noticed that that was the only way for the three laws to work together.
Ne kurangi thonang khari chung la na dinde imbai na tentim sumja takta digdu la jora di nye res kurangi.
And since that time, there are many experiments, careful experiments that we could do to actually confirm those laws.
Tangone tentim sue da dijela lo mangbu dra Newton kuran jela dig jela an ngaran ju takji mangbu ji che cha res tigala.
These are the laws, in part, that allowed us to put a person on the moon.
Ta di tentim gi ta kenge ani ngaran ju thanda mi wa tawal ta da dinde che thu yo res.
And so the importance of those laws is that they are applicable to any physical situation as far as we know.
Ta chisu gi ne dang jora khande ji imbai na ta tentim din ju laga chi yo res khawa imbai na.
So they are as relevant to objects that are rolling on floors
Tak ngobo khande ji mane shala gala rini duda dinde dungi imba inai res.
as they are to the movement of the celestial objects.
Anga jo khaing la ya ding yora ngobo dinzo imba inai re di changma la tentim di dugu yo res chi buji kyang tudang.
Until Newton, they were two different realms of existence.
Rangini dubala da dinala ta yawani desendo ni so na ta mindo ji shagre simba di tentim di todang thagrang dugu yo res.
The terrestrial realm and the celestial realm.
Ta thanda she dila realm la ni tan realm la thanya khari shebe namje realm kham ra kham kham ro ra da kham loga so na chik sagala thanda se khola chagora terrestrial la ni di che chik khaing la yo dinde ni so yo ainas ra.
The terrestrial realm extended until the moon.
Ta thanda terrestrial la ni thanda thangi ji shaswa sa da de logora di khagas paduli gor la na kham di tawa paduli yo res.
And the celestial realm extended from the moon to all the heavens.
The celestial realm lana khaingi thanda tat khamjora di kho chawor lana tawa ne chinen di thala khaju yo di sama ta phayudo lawra di sama chudu res.
People had noticed that in terrestrial realm there was change and defilement and deterioration.
Ta thanda kunzu gi di kharik thon lana terrestrial realm sai thanda khamjora dinal thon res andinal nyam dugu yo ji thon res.
Object would move and would come to a stop.
Khachor lana ngobu denzo yogu chigi yo res yogu chio na shi gayo yora kagi yo thongu yo res.
Whereas in the heavens there were these perfect motions of the celestial objects.
Ineta layugi khamdolan ming shada di ro cha shawana ngobu denzo yogu chiwana yogu che dig du la jora tharan ro dig duslan di thon yo res.
And Newton, with his three laws that we discussed, was able to combine the terrestrial, an explanation of the motions in the terrestrial realm with the motions in the celestial realm.
Ta danda ni yawani che shara khamni di an Newton gi kharchir lana tentim sum di tene di ni totan chikpare lani nyamdo chikla du shares.
So sort of specifically being able to connect how we see objects moving on Earth to how we see Jupiter or the other planets moving.
Ta ngobo den jung anju se khola la la khandi chigyo me dida ya kham di sa shemba ta waina sa pubu do ta waina dinde na la khandi chigyo me pensu jar wainas.
So the celestial realm means when you look up at night and there's a clear sky, all the stars and all the objects you can see in the sky.
The celestial realm na khaingi ta kham di laura di ro cha shawaina anju gonda ya ta du gala nam la thungu da din jo chudu yo res.
You know, it's interesting that from the first many hundred years of what we call science, the people that did this work were called natural philosophers.
Ta lo nyemma ni thanda laga di chali di nang de res di daji che din so khunjo la har la gor la na rangjung taduk ma wala lagi res.
They were philosophers of nature.
Ta khunjo taduk ma wala ni khari ka cha de la na rangjung khang ga cha de res.
So they were trying to create philosophies that describe the natural world.
Ta rangjung kham gi nanglo la ta khari khari chunggu me jora dil ta ne en khoran so taduk din so phiju chi gi res.
So you can also think of Newton's laws as a philosophy of the natural world.
Ta Newton gi tentim jora di kheran so gi ta rangjung kham gi tentim taduk do ji chasha na itgi res.
Not to say it describes everything about the natural world, but it describes the motion of objects in the natural world.
Ta rangjung kham gi changma gal de she gyagi rolan di shi gi mares ngobu din ju yama yogu chidang jora di galan de she gyagi res Newton gi tentim di.
That is why we actually have given you lots of examples to think about the forces and draw diagrams.
Cheza anta shub gi gala remove mangbush tijura di chiju kheran ju samlo tang ju is.
Because it is not enough for us for you to have heard these laws. It is not enough to have heard of the laws.
Dila dugala ma she deoina thanda tentim dire lan she deoina dangi ji chagi mares chezan susu rangi chini ta remove uthi chi oina ko ya chu res.
it has been important for us, for you to be able to struggle with the consequences of the laws.
Dila duta kiranzu nguni chene susu rangi lalinta ni thanda ta tintim dinzo lega chidang da ta dinde china dumde dinde ragdu la jara susu rangi chechu yins